Hi all. In this session, we are going to see what is a class, what is an object. We'll try to understand. As we are aware of that, class and objects are the object-oriented principles. In the previous sessions, we have discussed what is a uh, object-oriented principles. So which language we are calling as a object-oriented programming language, and which language we're calling as a procedure-oriented programming language. So before this, we used to have procedure-oriented programming language. If you by using the procedure-oriented programming language, if you develop any distributed applications, we have some limitations. In order to overcome those limitations, we are using object-oriented programming language to develop the distributed applications or internet softwares, we can say. So these are the 8 object-oriented principles. Any of the programming language, it contains these features or it satisfies these principles. That programming language we are calling as a object-oriented programming language. Java, .NET, Python, Ruby, all the examples of object-oriented programming languages. These are the object-oriented programming languages because it contains all these features. Now, we'll see in the Java. See, however, the way of implementation is vary from one programming language to another programming language. Their syntax is different, and other programming languages syntax is different. Now, let's see in Java how they have implemented class and object. What's the concept? I mean, how they have implemented. Let's try to understand here. So, I'm just taking one example to understand clearly what is a class and object. So if we want to construct house, what we do? We can consult one architect and we tell our requirement. Like we need one two BHKs we need and two floors we need. So based on our requirement, what they will do, architect will do, they will design or they will draw one sketch, right? They will design or draw one sketch or blueprint, we can say. They will draw and they will give us. Based on the sketch or we can say blueprint, we can construct our houses, right? So let us consider based on this, we can construct one house. And same way, n number of houses we can construct, right? So blueprint, based on this blueprint, we can create another house also. Let me write it here. So let us consider I want to create one more house. I want to construct one more house. We can create based on this sketch, right? I can create one more house. So n number of houses we can create based on that sketch or blueprint, we can say. So we can say this is a original copy which they have architect will give us. So n number of Xerox copies or n number of houses we can construct based on that original copy or based on that sketch, we can say. So based on this example, let's consider this is a class and this is an object. So based on these examples, we can define the definitions of a class and we can define definitions of a object. So we are saying what is a class? Class is a blueprint of an object, or we can say uh, uh, actually before moving these definitions, we'll try to understand one more concept. When you want to draw a sketch, when you want to create a blueprint, then you need memory, right? There is not required. Memory is not required. But if you want to construct the house, the space is required, right? One place is required. Then only on that place only you, on top of that you can build the house, right? So we can say that it contains the memory. But in the class, we no need memory. Here just logically we have. So, but here it is a physically existence house. So that is the reason memory is required. Okay, now we can define a few definitions. What is a class? We can say class is a blueprint of an object. What is a object? Object is in a instance of a class. So based on that class only we can creating, right? I mean we're constructing, right? That is the reason instance of a class. Instance is nothing but a it will allocate memory for the class data members and methods that we'll see after some time. So we can call object is a instance of a class. So based on this example, we can say it is a model, right? We can consider class is a model. Model for what? To create an object. This is a one definition we can say. And the other way we can say this is a template to create an object. We can say what is a class? Class is a template to create an object. Class is a model for create an object. Class is a blueprint of an object. So n number of definitions we can make it based on this example. What is the object? Object is an instance of a class. For class, there is no memory space is required because this is a logical existence. But object is a real world entity. What is a real world entity? Real world entity is nothing but anything it exists physically in the world. Let's take example pen, book, whatever. I mean, if it is physically existing in the world, the chair, anything, we can consider a number of things. So any entity which are physically exist in the world, that we are saying as a real world entity. Let's try to understand clearly here what is a real world entity. Let me take a few examples. Suppose vehicle. Have you seen vehicle? No. But we have seen type of vehicle like bus we have seen, car, truck. If I take another example, fruits we'll take. I have not seen fruit, but I have seen type of fruits like mango, apple, grape. So like this number of fruits we can see. Have you seen animal? Animal we have not seen, but we have seen type of like lion we have seen, cat, rat, dog. So all these are the, if I consider this, all these are the physical existence, right? So real world entities we are saying because it has state and behavior. That means what? What is a state and what is a behavior? We are saying that all these are the objects or real world entities because all these are physically existence. Okay, so and another way, all these are containing state and behavior. What is state and behavior? Let's take one example. Let me take one. Dog is a, we are saying real world entity. Okay, what is the state of dog? State we can say color of the dog. So color we can say, and the name of the dog. This is a one state, and breed of that dog we can consider. So all these are the states. What about the behavior? What it will do? Behavior means what actions it can do. So if I consider dog wagging tail, right? It will wag tail, and also it barks, right? Barking, and also it eats. So all these are the, we can say, behavior. So out of this example, we can say this one more definition for an object. What is an object? Any entity that has a state and behavior that we are known as an object, that we call as an object. So all these states, like I mean, state we can say this. We can say uh, variables, right? Variables. And what is the behavior? Actions. What actions it will do. So these things. And okay, if I consider, go back to here. Okay, what class can contain? What object can contain? Classes contains variables and methods. Variables and methods. What object can contain? Object also contain variables methods, right? Because we are creating an object based on the class only. Whatever we have created, I mean, logically, for that we are creating an object. So obviously we are creating memory for the class like variables and methods. So in the object also variables and methods only it exists. So variables we can call it as a synonyms, like we can say properties, we can say fields also, we can say, we can call attributes, we can say data members also we call, right? Data members. So all these are the synonyms we can call with any name. So this is comes under variable. Okay. What about methods? In any other way, we can call methods in programmatically we can say behaviors, and also we can say actions. So we are saying that class contain variables and methods. What the object can contain? Object also contains variables and methods. Okay. Now let's see. Before creating class and object. Before creating class and object, they will in general, I mean in real world, what they can do is they will draw some diagrams. We have some uml diagrams. We have uml softwares, we have or rational rows we have, and also turbo analyst. So based on this, by using these softwares, they can design the first classes like uml diagrams. What does it contain, all the things. Suppose if I take one student class, what type of variable it should contain, all the structure they will maintain, like student number, name, student marks, all these values, I mean variables should be available. And after that, methods, what methods we should get total marks. So this is one method should return, and also get grade based on their score, right? I mean marks. So what type of data type it is, what type of data type it is. So based on the need, they will design the data types. So all these things we are calling as a data members or variables, we call it as, right? Or attributes. And all these things we are calling as a methods or actions or behaviors. So in this way, first before implementing these classes, right, implementing the classes, they can design some uml diagrams, so by using some softwares. This is about the before creating the class they can do. Once they will create this thing like diagrams, they will implement this part. How to implement? So first I'll just try to create the class. So how to create the class, let's see syntax. So class is a reserved keyword. Okay. And class name. Class name is a user defined. You can give any name of this. So you have to start the braces. And so I have to define the variables, return type of that variable, and variable one, and return type of, suppose a number of variables you can create based on your need and based on your program need. Okay, you can create a number of variable. And similarly methods, right? Return type, what type of returning values, and also method name. Suppose method name is m1. Parameters, if we need parameters we can pass it. If not required, we are not passing parameters for the method. However, we will see what are the different types of methods and what is these parameters, why are we passing, later we can understand. For time being we can understand class contains data members and methods. All these are the data members or variables we are calling, and these are the methods. So you can create em2 method name. This is a method name. You can define user define, can give any name. This is also variable name, also user define, you can give any name. So like this we can create methods also. You can just close this opening bracket and parenthesis and closing parenthesis. After that you can close the class. So in this way we can create class. This is a syntax to create the class. However, we will see, I mean, we'll create and we will see. First, let us focus on syntaxes, how to create. Now, how to create an object. So try to understand how to create an object. We are saying object is a instance of a class, right? So let me take one example. Without a class, can I create an object? No. If you want to create an object, you should, I mean, class should be available, right? Then only you can create the object. So now let me take class. I have one class called robo. Robo is my class. Let me take one variable integer here. I have one variable in my class. Let me take one method. Suppose void. Void means it is not returning anything. Display is my method name. Okay, just close it. So let us consider we have a one robo class. Okay. Now, let's see how to create a object for this class. So syntax is how to create an object. This is a class name and object name. Object name is a user defined. You can give any of the variable, and equals to new. New is an operator. We'll see what does it do. And after that, class name, you can, this is a constructor. We'll discuss about this constructor later. Now we can consider this is a syntax. Just if you want to create an object, you have to follow this syntax. What is a class name here? For this is a class name, right? My class name is robo. And object name is, as I said, anything x, y, any variable user defined. You can give anything here. Now, after that, what is the syntax? New. After that, class name. What is the class name? A robo. This is a constructor. Okay. So this is a syntax to create an object for a class. Okay. What will happen if I create like this? So what will happen is immediately when I create an x, suppose x, it will x, right? So what it will does it do is new operator automatically will create a memory space for object. Okay, x will create. So for whom it will create memory? For this class, right? For robo. Where is this class? Robo. What are the variables and methods available in this class? This is one variable, this is one method. So int a. So a, for a it will create one memory allocation. What is the type of integer data type? Okay, by in Java integer data type 4 bytes. 4 bytes it will allocate. After that, how many variables we have? Only one variable. If we have multiple, for that also it will create variables. I mean memory. So now this is the display method, right? For display also it will create memory. Now let's try to understand what is a new operator. What does it do? Okay, so memory, new memory, like we can say new operator. Whenever you can create an object, if you create by using new, right, it will allocate sufficient amount of the memory for the data members and methods of the class. This is the first one it will do. And second one, it will take the loaded class of reference. Suppose it will whatever, I mean robo class, right? This is your loading, right? This reference, whatever, I mean wherever it is present, all this reference it will take it and it will place into the left side of the variable. That means object name. X is object. So in this way, or else in other way, simply if I draw, suppose you are saying that one x, right? Yes. Okay. You are holding one variable a variable equal to 10, some methods 20, like this. Okay, so wherever it is available, right, all this memory loaded class, with respect to loaded class, it will take this memory and it will place into the x contains this memory, like where exactly it is available. So these are the two actions. So what's a new operator does? It will allocate the memory for your data members and methods of that class. And also it will take the references where it is available in the memory and it will place that reference into the object name. So this is about the new operator. Now, next, let me take, what is this RoboX? Okay, let me take one example. Here I need to explain one concept called, okay, let me take example one so that it will be clear. Int a. What is int a? String b. Okay, what is int a here? What is a here? A is a variable. We know that variable of integer class, right? Integer type. What is b here? Variable of string class. Correct. Here, what is x? Okay, here I am saying robo x, right? Class name x. Okay, what is x here? Variable of type class. Variable of type class. See, here integer, string, float, double, all these things are, we are saying as predefined data types, right? Earlier we discussed predefined data types. This is a user defined data type. Okay, here we can remember this. What is this object is? Object is nothing but a variable of type class. This is a one variable. Which type is this? It is a type of class. Variable of type class. This is very important to understand. We know that this is a class, is a class, and interfaces and enumerations are, these are the user defined data type. So this is a one concept. Now let's try to move further. Okay, let's try to create one class here. So let me write one class. Okay, add, I'm writing. So if I declare n, I'm taking additional program. I'm just simply taking a, b, t. Three variables I have taken, and I'm just taking one method, simply some method, a equal to some value, b equal to some value. Just I'm returning a plus b. I'm holding into the t. Just you'll write system dot out dot println. However, we'll see what is system dot out dot println later. Sum is plus t. So if you want to concatenate this, print this variable, you have to add this plus operator. Okay. Now you can close this method and close this class. Okay. If you want to execute this program, it won't execute. Why? Because Java always first, JVM checks the main method in your class. Main method is not there in this class. So what we can do is we can create another class, main method class. Then we'll call this. We'll see here. Let me take one main method. Suppose add is a main method. Let me take one main method and public static void main. We'll see what is public static void later. String of args. And so now create an object for which class? This class, right? Just go to how to create an object. Class, object name. Suppose X is my object name and new is operator and class constructor, right? Add like this. Now, what happens? What happens if I create an object? As I said earlier, first it will create a memory for X. For which one? For which class? For add, right? Where is add? Here add is there. Add what and all available? Here variables and here methods. What's a variable? How many variables we have? A, B, T. Three variables we have. For three, it will create the memory. What is the type? Integer type, right? 4 bytes, 4 bytes, 4 bytes it will operate. And what else we have? Methods, some method, some memory space it will be created for method also. Now, try to understand here, this is a instance variable. What is instance variable? Whatever you defined in the class level, those are the instance variable. Why? Because n number of times it will create the memory. That means whenever you create an object, suppose the first time I have created an object, right? So it will create the memory. And similarly, if I create one more object, n number of objects you can create for that class, right? Suppose if I create another object, again x2, and again one more copy will be created. That is the reason we are calling as a instance variables. All the class level variables, declaring variables, those variables are we are calling as a instance variables. This is a remember this one also. And next, so coming to this, what happened? I have created an object. Whenever I created an object with this object name, memory will be created for variables and methods of the class. Done. Next, what is the logic here? Where from where logic should execute? From the main method, right? Okay, this is done. What is the next? I have to logic is here. I need to call this method, right? How to call x dot? What is the method? Sum. If I call this, close this method. What happens? X dot sum. Where is this x dot sum? Where x is here, right? X is here. Okay, sum it will go. Where is this sum? Control will go to here. Sum method. What is written in here? A equal to 10. 10 will place it here. What is a b? B equal to 20. What is a t? A plus b. 30 will be 8. What is the next? System dot out dot 30. So output we get as a 30. So in this way, program will execute. Okay, let's quickly try to, however, if you don't want to create separate classes within the main class only, you can write this logic. We'll see, two ways we can implement, but in real time, we have n number of classes. So, multiple classes, we can say, multiple classes based on our needs, we can create it. In the main method, we can call all the logic and we will execute this. So first we'll try to uh, create and execute this program. So already I have written, if you see my screen, whatever we have discussed just now. Let's observe. I have created one class here. Add is my class name. I have taken three variables in the class and one method I have written. I am just initializing the values to that variables a b. I'm just printing sum is t. T is nothing but 10 plus 20, 30 should be our output. So this is a one class. Okay, this is a separate class. So in this class, we don't have main method. Okay, so that is the reason I have created separate class for this main method. This is a add is a one class. So here we have main method. In this main method, I am creating an object for that class. For which class? Add. For this class, I am creating an object. My object name is X. So whenever I create an object with respect to this, the memory will be created for this class of data members and methods, whatever available in this class. And after that, I'm just calling the that method with respect to object. What will happen? Sum, right? It will the entire thing, it will logic, and we'll get the output. Let's try to quickly compile and execute. We know that Java is a compile and interpretation program, right? Compiler and interpretation program. So let's try to compile first. So just try to command. So how to compile? Give Java C, and what's the program name, class name, or add Java. Okay, yeah. See, so there are no errors. Compile. See, whenever compile, see two class files it will generate. Class files are nothing but a byte code. It contains the byte code. Who will provide? I mean, who will create this byte code or class file? Okay, this is a JVM. Okay, JVM or compiler. Sorry, Java compiler. So set of instructions, optimized instructions, we can say it is generated by the Java compiler first. Okay, so it will generate the two class files. That is nothing but a bytecode. If you see here, this is an unreadable format. Bytecode, we can't read this. Okay, now compilation is done. What is the next? We have to execute it, right? How to execute? Java, just program class name. Okay, just enter. See, sum is 30. We have received, right? So this way. And second way, as I said, I don't want to write separate classes. Okay, within one class only we can do that. So let me take this one file. What I can do here is just deleting this. See, I'm just writing only one class here. See, main class only just one class I have written. In the class level, I have taken three variables. We can say these are the instance variables because every time whenever you create an object, memory will be allocated for this or created for this. Okay, I have just taken one sum in the main method calling that just creating an object for this class and object for this sum, calling that method. That's it. So here only we are using one class. Just quickly save it and try to run it. What's the class name here? Main class, right? Main class dot Java. Then next, how to execute it? Java. So when you compile it, see one class file generated, that is my bytecode generated. After that, just execute this program. See, sum is 30. So within the one class also you can write it classic. Now let's try to understand how Java program executes. What happens internally? Okay, just now we have seen one example, right? We have seen, my class name is madd.java, right? So this is my program. Okay, I have written one program that is named as madd.java. Okay, so how to compile? First, we have to compile this, right? Java C madd.java. Okay, file name. Okay, so when I compile this file, what happens? Java compiler will give us the one dot class file, right? Madd dot class file. This class file we are calling as a bytecode. Okay, it is generated with the Java compiler. Okay, once compilation phase is completed, what we have to do? We have to execute it. Java and file name madd. When you execute it, there are some operations will happen internally. What are those four operations? We'll see. First one is class loader subsystem. What is class loader subsystem? Class loader subsystem is a one internal program developed by Sun Microsystem and provided as part of the Java software. What does it do? It will take this class file from the secondary memory to the main memory. It will place into the main memory of the computer. That means RAM. Okay. Once it is available, this class file is available in the RAM. What it will do is JVM will pick this RAM, file, the dot class file, and it will pick the file, and JVM will check for the main method of the program, like where that main method contains, where method is available. Once it detects this main method, then it start executing the program based on the steps, main method with respect to the main method, whatever the logic it has, right? It will execute the program. So this is a execution flow happens in the Java. So in the next session, we'll see different types of data members and different types of methods. Just in this session, we have understood what is a class and what is an object. Next session, we have see different types like instance data members, what are the static data members, and what are the instance methods, what are the static methods, how to call those things. All the things we can discuss in the next session. So yeah, that's it. Thank you all.